following is a production of the Event Safety Alliance.
And welcome to the Event Safety Podcast. This is Danielle Hernandez of Furman University and the Event Safety Alliance. Today, we're going to continue our conversation about counterweight rigging. We're going to start with where we are now and then move forward into where the industry is going with that particular technology. I'm joined again by Ethan Gilson of Entertainment Rigging Services in Massachusetts and Rick Boychuk of Gridwell Inc. in Toronto, Canada. Hello, gentlemen. Today is April 22nd, in case we talk about anything that is date specific. So last time we left, we had flown something up into the air. At that time, it was a light, but we're going to change that now. Now we have hanging in the air this big, beautiful steel frame flat. It's really heavy and it's not in panels, so we can't really take it apart as it comes down. So we need to work out how we're going to safely, since the counterweight rigging system works by balance, how are we going to safely get this thing back to pipe weight when we take off this scenic element? And you can use your imagination for what show it's from. It doesn't matter. All right. Who wants to go first? I pick Ethan.
All right. Well, this is a very common situation, everything from scenic flats to even just your drape. As those objects touch the floor or pile up on the floor, as the case of a drape would be, obviously you're changing what your payload weight is. I hesitate to say weight because when you get into the math side of it, everything's a force. So you don't want to complicate things by saying pounds and weight, but we'll use those for now.
We have a teeter-totter and we have jumped off at the bottom.
Yep. So this hard flat, when you fly it in, the deck's going to start eventually taking some of the load of this. And when it does, you no longer have that payload on your line set. So the question is, how do you deal with that compensation? The thing that a lot of people tend to do, which I will say is probably not the best practice, is that you get as many people as you can around that operating line and you muscle that line set in and you get the arbor all the way up, and then you use some method of additional securing on the operating line, whether that's a bull line tied to the operating line or people joke, a broom handle that's twisted through the operating lines, or what we would call a spike. Some people have developed devices. One of them is called an Uncle Buddy, which has a love-hate relationship in most of the industry. Some people love them, some people hate them. All of those are designed to add friction to the operating line to assist the rope lock, which we talked about last time, is designed only to hold 50 pounds of imbalance. And clearly in this situation, we're way over that. So now you've muscled this in. You've created an inherently dangerous situation where you have all of the counterweight at the top by the loading rail. And in theory, if you're still managing okay, at this point, you would unload the weight so that the arbor gets down to what we call pipe weight, which is the minimum amount of weight to keep the system in its normal balance with nothing hung on the pipe. And we'd go from there. Well, as I said, there are a lot of issues with this. You're potentially or likely overstressing that operating line, the rope lock. There are some inherent dangers to the different processes of additional securing. So the proper way of doing this is with some mechanical advantage. That could be an additional operating line that's tied to the bottom of the arbor or to the top of the arbor. A lot of the time, what people have done is block and falls. You find a secure location to attach the block and fall to the building structure. You attach it to the bottom of the arbor, and you use that mechanical advantage to help you deal with an imbalance. And what you actually end up doing is unloading some of the weight from the deck level, creating an imbalanced system so that your pipe is heavy, and then you ease out the arbor towards the loading gallery and deal with that way. It's still not a great solution because you get into the minutia of the individual components of that line set. Are you overloading where you attach that block and fall to? That's the same basic idea of what is known as a capstan winch, which would be a winch in historically they might have it on a track that would go upstage, downstage by the locking rail. And you would put an additional rope on that, and it would give you that mechanical advantage to attach to the bottom of the arbor to deal with those imbalanced systems.
Okay, so I've been in some really old theaters just as a tourist and never seen one there. Rick, do you normally see them when you go to the really old ones?
I'll tell you the truth. I have never seen a capstan winch in a theater. I've seen them offered. I've seen them sold and bought, but I've never seen one
actually in use.
Yes.
How interesting.
Ethan, your experience might be and probably is different.
I've never seen one in person. Usually it's in that historical catalog or online in photos. I think part of the reason for that is human labor is cheap, especially in academic institutions where you have lots of students, and some of those other solutions are more expensive. So, hey, we can just put 3 or 4 people around this operating line and pull like heck and achieve the same thing.
So what's your guys' opinion on things like a bull line on the line set itself? So you have additional people pulling the line set in, not on the operating line, but on the actual pipe.
The ANSI standard requires that the line set be in no more than 50 pounds out of balance. And to conform with that, you want to maintain that. A bull line is actually one way to do that. You're going to add, I'm just shy of 200 pounds myself. If I'm on there, I add 200 pounds. We put 2 or 3 bull lines on there. We've got 400 or 600 pounds adding to the balance, pulling down.
So for our audience, if you don't know what a bull line is, it's basically a rope that you sling over the batten itself, or you can attach it other ways if you can get to it. And then the stagehands on the ground actually pull on it to help pull the pipe into the ground. Sorry, go on, Rick.
Frank Cortez, I don't know if Frank will ever hear this. Frank Cortez is the head flyman at the Long Center in Austin, Texas. And he's come up with a brilliant device. Now, there's something to remember. That heavy piece, when you want to remove it, you will have to have put it in place. So you will have had to overload your arbor and hold that batten down until that piece got fully suspended. He's developed a rolling pin rail. It's got 2 pins. It's got 1,000 or 2,000 pounds worth of weights on it. And so when that piece is going out initially, he would lash 1 or 2 of these rolling pin rails to his lift points. And then that line set is in balance because his rolling pin rail is giving the counterweight. And then, being a pin rail, he unlashes it and slowly lets it out, and the other stagehands control the piece. And then once it's fully in the air, they just let the rope go, and the rope's permanently in place. Not permanently. It stays there. And it's there for the out as well to be the bull line pulled on by the stagehand.
To bring it back in. That's brilliant. Is there a place we can look at that online?
No, I do have images of it. He sent me some images.
I might also have some images of the same thing, but taking to the next step. At the Boston Opera House, they have a mobile pin rail, which they call, I believe, an Uncle Larry.
To go with our Uncle Buddy.
Exactly. And instead of using a rope, they've attached a 1/2-ton chain motor. So now they have the mechanical advantage of the motor attached to, and I think theirs is 1,500 or 1,600 pounds for a 1/2-ton motor, which actually has an 1,100 pound capacity. And they'll do the same thing. I would want to mention that the important thing here like I mentioned before, you have to look at the individual components of your line set. So when you do this, the weakest part of your process there is probably the batten. So what you want to do is you want to make sure you attach your bull rope or your chain motor or whatever it is you're using as close to a lift line as possible. But you also have to know what the capacity of your lift lines are. In most theaters, they're 1/4-inch wire rope. They have a braking strength of 7,000 pounds. We, at a minimum, use an 8-to-1 design factor, meaning we divide the braking strength by 8 to get a 850-pound working load limit. So we don't want to put more than 850 pounds of stress on an individual lift line. So you have to consider that part of it so that, yes, you're solving one problem, but you don't want to inadvertently create another problem.
I'm going to add to that another caveat. If you've got a good brand of counterweight system, you're going to have a certain load rating on your loft block. If you don't have a better brand, your loft block might only be rated at 400 pounds.
So lots of considerations.
You have to know what Ethan has just said, and I like to believe you have to know what I've just said. You have to know where the weakest link is. And that's why when I said one or maybe two of these that Frank would use, it's because sometimes if you're only dealing with 400 pounds, one lift line, that's all you need. If you're dealing with 800 pounds,
you want to spread it out.
Exactly.
So it's arithmetic, and this is what the head flyman has got to understand.
I will say something that I learned when I was in college, and it's something that sticks with me to this day. Typically, when you're moving soft goods, so we're talking about 100 pounds of imbalance. We're not talking a significant amount of weight, nothing that you need additional.
That depends on the haul.
True. But let's say,
let's say it's about 100 pounds.
150 pounds. A lot of theaters, they'll overhaul the line set in. So they'll muscle the line set in. And then they'll have, let's say, the deck electricians go and place their arms on top of the batten to help hold it down. And one of the things that we were always taught was don't lean your head over the pipe batten. Because if it were to move, you don't want it coming up into your face.
You don't want to lose teeth.
Exactly.
The bottom of your jaw slams into the top of your skull. Yeah. You should never be over a pipe.
Correct. I still kind of think there are better solutions to addressing the situation than that mean a little more control.
I mean, you can have people hang on a pipe without being over it.
Yes.
Yes. Yeah.
So, Rick, you had something you wanted to...
Oh, no, I was just going to say guilty. When I was starting in the industry, the theater that I worked in, I was 22 years old, and we just draped over the batten with our arms, and our arms and our face were in harm's way. And I'll tell you, we were never trained. That was a long time ago.
Well, and at 22, you're all
immortal
at 22. So
I relate the story when the first time I loaded. Okay, you're up on the loading gallery. Okay, I had no idea what that was. Go up to loading gallery. Okay, put these bricks on there. So I had to crawl into the well, and I'm being handed bricks, and I'm saying, "Why are we doing this?" I had no idea. Shut up and keep doing it. That was my training. We've come a long way since then.
Yes, that's a little terrifying. But I'm glad you survived and nobody got hurt.
But it depends on the head.
Sure.
As workers in this environment are dependent upon the head flyman to understand that he or she knows what's going on. And so often we don't have knowledgeable stage crew. We have people that have never done this before, have never done it often. I speak with TDs and or stage carps at various places, and they get a Broadway show in 2 to 3 times a year. That's it. They have to change their arbor weights 2 to 3 times a year. And they're small cities. Their crews aren't experienced at this. When the big show comes in, they have to pull extra crew, sometimes off the streets, sometimes from sister locals. They're not going to get the best people. It's that person calling the job that is crucial. They've got to know what's going on, which is, I think, off topic.
Well, a little bit, but it does pull to the point of it's really important when it comes to rigging, as we said last time, that somebody in control understands what's going on, because the risk of this using the system improperly can cause injury and death. And it's important that we help teach people. You know, I frequently have people that have never done anything in a theater ever before. And I'm like, okay, today you're going to do this. And, you know, you can't train them on everything in one day, but you can train them on what they're doing that day. You know, if we have a pipe in, don't hang over it.
Yep. Well, I think
start somewhere.
I think it's a good opportunity to have a Jim Digby moment, which is we're often working under that condensed time frame, and we have that mindset, the show must go on safely. If your crew's inexperienced, you need to know how to articulate efficiently, which, by the way, I'm guilty of not always doing sometimes, the procedure that you're going to follow. Hey, this is what we're going to do. These are the steps we're going to follow. Here's what you need to be cautious of, and then to take it slow and to make sure that everyone's doing the right thing. And also always give yourself an out. Always give yourself an ability to get away from that area where you have that potential hazard, which is why we clear the rail. Even though I trust the people up on the loading bridge, something can happen where they drop a weight and you don't want to be underneath where they drop it. So I think communication is a very important part in that process where you're not using mechanical advantage, you're using human power.
Okay, so we have started to unload from the counterweight Arbor that's up at the grid. There have been a couple innovations in Arbor design recently that have been safer that a lot of crews are talking about that they really prefer. Rick, could you talk to us a little bit about front-loading Arbors and what exactly that is?
Okay, in disclosure, I hold the patent on the front-loading Arbor. And so I've got an interest in talking about this that goes beyond just the topic. But I just got the feeling one day we could do it better. My daughter came home with one of those CD cassette towers, you know, where you store your CDs in this tower. And I looked at that and I said, that's brilliant. Why are we loading from the side and all this hassle when we could be loading from the front? So I played with it for about 6 months, and I came up with a front-loading Arbor. The idea of always loading an Arbor from the bottom, and when we offload it, we're always offloading it to the bottom. Why don't we just have a front-loading Arbor with shelves? And we can just choose. Most of our, Ethan, well, both of you work with counterweight rigging systems. Few of our loads are heavy. Some of them are 1,200, 1,500 pounds, but a lot of our loads are 300-400 pounds, you know, 60 pounds, just a drop, 90 pounds. But if you've got a rod Arbor, you're always starting that at the bottom. And with a front-loading Arbor, you just choose the shelf that's right beside you. We combine that with what I call a shelf. You put all of your bricks on a shelf. So the lowest brick is 24 inches in storage. And so now you can actually work on the balls of your feet, not on your hands and knees. When in the Netherlands, they did an actuarial analysis and they said, well, in the Netherlands, counterweight rigging is illegal. That's not quite right, but it's good enough for our discussion. They found out that people running counterweight rigging were getting back injuries more than any other stagehand. And so they went to find out why. And there were two reasons. The one that we're talking about now is the loader has got to work on hands and knees, pick up a 20 or 25 or 30 pound brick on his or her left and shift it way over there on their right. And so they're twisting their back under load and reaching out under load. And this was causing back injuries.
Yeah, it's a classic material handling problem.
It's not something particular to our industry. And so the idea behind the notion of having somebody working on their full flat on their feet and turning on the balls of their feet, not twisting their back. With a rod arbor, you have to reach to the back of the arbor, and sometimes that's full 20, 22 inches away. You have to to do the work, reach to the back. With the front-loading arbor, you just put it at the front of the arbor and slide it in. And
so it's an ergonomic solution. It's also safer because you're not having to manipulate something at the end of your reach to manipulate the brick into the. I'm doing all these gestures that no one can see.
A very common practice in a lot of theaters is to either have in older theaters, cut out the railing so you could get access to the arbors, in which case now you have an exposed leading edge, or to do chains as a removable railing. And as we got better, we said, well, if we do that, we need to have additional fall prevention, whether that's fall restraint or what most people tend to go to is fall arrest. And the problem is, it's not enough just to have the harness and the lanyard, but you have to have an appropriate anchorage. You have to have a rescue plan. You have to do training. And it can be kind of expensive sometimes to do a properly designed fall arrest system and to train the people to use that. And so if you eliminate that risk, if you mitigate the risk of the railing, you've solved that situation. And it is something to consider in terms of when you're looking at some of these technological advances and people start looking, well, what's the cost benefit? Yes, it may cost more for this one widget, but here are all the other things that we no longer have to worry about in terms of keeping our workers safe.
If I may speak to that point, there's an installation going in this summer in Canada, and the installation is 42, the existing system is 42 years old, elevated operating rail, a mid-rail, and a loading level. They've never had safety rails. And in this project, we are putting in compliant safety rails, because with the front-loading arbor, the rails are not at all in the way. We've done this so many times. And so we can now add that thing that adds to the safety of your galleries.
Right.
I would also say that if you have a double purchase system, you should very much consider front-loading arbors, because that just enhances the challenge of the well-placed loading bridge at an elevation where you can reach the entire height of your arbor. The big challenge with double purchase systems is your arbors are now usually twice as high, because you have to put twice as much weight on them. For every pound you put on your batten, you need 2 pounds on the arbor. So there are a lot of advantages that people didn't start thinking about until after they started getting some experience with the front-loading arbors.
Yes. One of the first installers of the front-loading arbor was a theater that had a curious situation, 47 lines single purchase, and then upstage 14 lines double purchase, with one height gallery. And they were, for 40 years, they were crawling into the well. They then cut their gallery and lowered the upstage portion by 3 feet. They were still having to crawl into the well, but not as deep. With the front, and most of the load, when you get upstage, I'm sure you'll agree, most of the load it's going to be a piece of drapery, it's going to be a drop, it's going to be a scrim, it's going to be relatively light. They had to crawl into that even if it was a 100-pound load. With the front-loading arbors, they just picked the convenient shelf and they just loaded up with 200 pounds. They're all set. I'm getting a bit embarrassed about talking so much about the front-loading arbor. It's something I'm very pleased with. What I can
solves
say,
the problem.
What I can say is that the people that have ever done the work love it. I was at a trade show, the one USITT in Milwaukee, and somebody walked up to the arbor and wrapped his arms and one leg around it and said, "I want these." That is gratifying.
I'll mention there's another advantage to them that I particularly like, from an operational standpoint, which is on a traditional arbor, you have what are called spreader plates. And you're required to put those in every 24 vertical inches of stacked weight. And those are designed that in the unfortunate situation of our runaway, when that arbor gets to its limit, either up or down, the arbor rods that are holding the weight will have a tendency to spread open. And if you don't use them properly, the spreader plates properly, you can launch your stage weight out of the arbor. You don't have that issue.
Compresses.
Correct. And I could share some very interesting pictures of arbors that are no longer linear, to say they're more S-shaped these days. With a front-loading arbor in those shelves, that's built in. You can't not use them. They're there. They maintain the shape of the arbor. So there's some enhanced features of them.
There's something interesting that nobody will have ever seen. I have, but I only saw it on video. And the reason I saw it you can't see it because it happens so fast. And here's what it is. When there is a runaway, your arbor drops down quickly, hits terminal velocity, and it hits the end point. The end point is not generally the bump rail. It hits that and just goes right through it, like a knife through butter. It does. And its end point is hitting the tension block. And what happens is that the bottom of the arbor stops and the top of the arbor actually continues for about another 3 or 4 inches. And then what happens that you can only see in video is the bottom of the arbor kicks out because those 2 rods have become springs. They've got that extra force, and I have videos of this. That shoe at the top jams because everything's distorted, and the bottom of the arbor kicks out about 2 feet.
Holy cow.
We had done this drop test with one of the manufacturers. It was outside, and we all made a mistake. It's not a drop test. We were calling it the wrong thing. It's an impact test. We didn't see this because we weren't looking. We were looking up. We should have been looking down. Fortunately, the video camera caught this.
Well, hopefully, if you have a link to it, we'd love to put that in the show notes.
I can arrange that. I think I've got it on my YouTube channel. But what I was walking past the engineer's desk the next day, and he says, "Oh, do you want to see the video?" And I said, "Sure." And he ran the video slow motion, and I looked at that and I said, "You know what just happened?" He said, "What?" I said, "We just broke the flyman's leg." He said, "What?" I said, "Take a look at where that arbor ends up in its travel." And it was a full 2 feet out from its position. Now, there would have been protection by the locking rail, as long as there was a locking rail in that location. But and then we looked at the front-loading arbor. And the front-loading arbor is like the crumple zone of a car. It just crumples. That's it. The arbor actually absorbs the impact. It doesn't put it into the springs being the rods. And that was totally unexpected.
So let's talk a little bit about motorized rigging, which is different than automation, but it has some similarities to automation.
I think motorized rigging is almost essential. I'd say it's essential on lighting battens and on acoustical shells. The lighting battens because we're always changing the loads. Acoustical shells because they're just plain heavy.
And there's a progression of options for motorized rigging. One of the first things was as similar to what we talked about, which is using a chain motor with some counterweight to attach to the batten. Well, you could do the same thing. Maybe you use a different style of chain on a motor to do what is called a power-assisted arbor. So maybe you have half of your payload weight in counterweight and a equally sized motor with the same capacity. So usually you'll see 1,000 pounds of counterweight and 1,000 pounds on the motor, so that on a lighting batten, maybe you have a connector strip. You wouldn't necessarily see this in a Broadway house where every batten could be used interchangeably, but in a facility for a school or something where you have connector strips, the counterweight is counterbalancing the things that are always there, the connector strip, the self-weight, the cable. And then the motor is dealing with that variable payload, the lights or the video or your backdrops. So that's the very first step in that progression. You can then go to a fully motorized line set where that motor is taking 100% of the load. You never add counterweight to it. There is something that popped into my head that I do want to mention, which is a lot of the manufacturers of motorized rigging will talk about enhanced safety features of the motorized rigging. And that usually is related to you're not dealing with an out-of-weight line set. You're not exposing people to the risk of loading the weight or improperly weighting the line set. I think it's important for everyone to remember that these are all tools. And you can misuse any of the tools. But if you are not, as we talked about earlier, properly trained in the use of those tools, you can still have accidents. And it's part of the reason why Rick and I tend to say it's not automated rigging. It's not something you can set and forget and walk away from. There is always a human operator that's involved that has to manage it. So it's motorized with an operator who's constantly watching and making sure that it is behaving the way we want it to.
That's fabulous. That ties right into all the safety things that I love about rigging. So they're all different kinds. That's a different dog, by the way. That one's Kaylee. The other one was Pepper. I've been texting my daughter, go deal with the dog. Sorry, guys. I really apologize. They're normally asleep this time of day.
Yeah, they're excited that we're here.
Yes, exactly. So there's different kinds of rigging that uses motors. Sometimes it's used for things that are extremely heavy that you would have to have an outsized counterweight system, and it's a standard load. Like an orchestra shell ceiling, a lot of times can be, it's a weight that never changes. It tends to be a very heavy piece. It doesn't need to move at a variable speed. It's typically moved when there's no one in that audience anyway. So that is a very common piece to be put on some sort of chain hoist or some other kind of lift. Are there other examples of things like that you guys can think of that would make sense that there would be a safety advantage to putting on some sort of motorized rigging?
There's been a trend in particularly high schools, new construction of high schools, to move towards motorized rigging for the purpose of eliminating students at height loading weight, the imbalance system of counterweight line sets. So you'll see systems that, they're doing every line set as motorized and changing the capacity so that they can focus their budget in the appropriate places. It's certainly no surprise to people that when you move from counterweight rigging to motorized rigging, it tends to be more expensive. And there's a lot of things to do to kind of play with the focus of those budget numbers, to say. With motorized rigging, some of the designs of the manufacturers eliminate some horizontal forces that you would see in counterweight rigging. So that loft block, so your lift line goes from the batten up to the top of the fly loft, and it goes through a pulley, which we call a loft block. There's a vertical load, and there's actually a horizontal load. That loft block's being pulled sideways towards the side of the building that has the arbors. Well, with certain motorized systems, you don't have that horizontal force. So if you're doing new construction, you don't have to have building structure to resist that horizontal force. So you might save some money there, and that money goes to paying for the motorized rigging.
So what are some limitations other than, well, there's a lot of maintenance that goes into anything that uses electricity and motors and with that.
I've written an article for TD&T magazine. I think it was in fall of last year. I was approached by the editor to respond to an article in the edition before out of Europe, where the Europeans are confounded that we should be doing counterweight in North America. They're moving all over to automated, to motorized. In my study of history, I see different dynamics between Europe and North America. Most specifically, Europe has a 350-year history of maintaining equipment. And I don't say that lightly. I say that the reasons are real. Their equipment up until 150 years ago was all made of wood, and it was constantly failing. A board here, a board there, and they always had to be repairing this equipment. And institutionally, they got to understand that. And so when they transitioned from wooden machinery to both counterweight and to motorized, they had institutions that understood that there's going to be maintenance and it's going to be expensive. The evolution in North America was different. We did not grow up in a time of wooden machinery, the very tail end of it maybe. Our industry grew up with counterweight rigging, which is a very robust technology. We've all, I'm sure, seen systems, counterweight rigging systems that have not been maintained for 10 years, 20 years, 30 years, and they're still working. What that has allowed us here to do is not build the institution of constant maintenance. So when we now get the opportunity to go towards especially automated rigging, we don't build in the maintenance costs. And the maintenance costs can be 10 to 20% of the capital costs every year. So we're not doing this.
Absolutely. I like to, when I'm involved in a project early enough, I like to mention to the owner that your rigging system is like any of your other mechanical systems, your HVAC or your cooling system. Okay, those are the same things. Your elevator, or if your school is really fancy and you have escalators, all of those things have moving parts and they need to be inspected and maintained. Again, if you go to tsp.esta.org, you can look at the ANSI standards, and we have an ANSI standard that's just being revised for how often you should inspect your rigging in your performance spaces. And it talks about the qualifications of who should be doing the inspecting to make sure that you're getting someone who knows what they're looking for, as well as a tiered system. It's like everything else. You have periodic and frequent inspections. So that frequent inspection as the user might be, hey, this operating line feels really rough, or hey, that motorized line set's making a noise it was not making before. Versus periodic, which would be the annual inspection where maybe you have an outside entity come in and do an inspection of your system to look at deficiencies. And they are usually going to be two types. There's going to be equipment deficiencies, wear and tear, as well as operational deficiencies. And it's important for facilities to budget that cost in their annual budgeting for maintaining the equipment. As Rick said, you can certainly get a counterweight line set to last for years and years and years. And what's going to happen is maybe the bearings start failing, so there's more friction. It makes it harder to use. If you go too long, certain things are going to start to fail, and you start exposing your workers to risk, like objects are going to start falling out of the sky. And that's what you're trying to avoid with your maintenance.
I'm going to go ahead and say that I don't like objects falling out of the sky. I don't even like snowstorms.
I cannot recall seeing operational failure. I've never seen a catastrophic failure of any rigging, automated, motorized, or counterweight. I'm sure they've happened. I've never seen them. What I see is things stop working. And if a counterweight rigging system, a rigging system doesn't matter what type, is mission critical. I sat on a board with ex-military, and everything the military buys is mission critical. And they budget 20% per year for 10 years, not for next year, for 10 years before they buy it.
That's fabulous.
Because it's mission critical. A rigging system is mission critical. If that piece won't fly out during performance when it's supposed to, your mission is thwarted.
So what it sounds like is there's the right tools for the job, that you need to inspect it and keep it working properly. You need to budget accordingly for maintenance. Sometimes motorized is the right solution. Sometimes counterweight is the right solution. I think we're all sort of biased on this particular podcast towards counterweight. I hope that didn't come across too much, but we do love our counterweight. And I want to thank Rick and Ethan so much for being with us. If you guys have questions out there in the universe for us, info@eventsafetyalliance.org. And we look forward to hearing from you guys in the future. Thank you all, and be safe.